This is TMUA question of the day 26 hints video with startmaths.com and Tobin Payne. So our A-level plus question today is one that looks a lot more complicated than when you try and describe it. So obviously we've got a pair of equations. They are equations that involve integrals. If I said to a student studying A-level maths, you've got a pair of equations and you want to solve to find something, you typically think simultaneous equations. Can these be written as a pair of simultaneous equations? Remember, you can say something like, let A equal integral between 0 and 1 f of x dx. You've got two equations, so you could also set a second substitution. And remember that the integral from 0 to 1 plus the integral from 1 to 2 is the same as the integral from 0 to 2, assuming you're integrating the same function. With our functions and algebra question, we've obviously got some sort of equation. What we're being asked to show are all inequalities. Where do you typically see this sort of equation? Now, be careful about trying to use logs. A lot of students will look at this and go, well, we've got exponential functions, therefore I need to use logs. It's not necessarily true. So think about what kind of equation this is other than an exponential equation, and what kind of equations can you easily arrive at inequalities, and pay attention to this idea of one or more real solutions. What kind of equations can you often find when it has one solution or more than one solution, etc. Now, our functions and geometry question is a real favourite of mine, so I'm glad Tobin's chosen this. In my experience, when students look at this question, they want to pursue an algebraic route. And again, one of the things we're trying to do with these questions of the day is help students distinguish between functions questions that should be solved using algebraic methods, like the one above, and functions questions which should be solved using geometric approaches. So, what I would say to ask yourself is, why would simultaneous equations not be solvable? So it's asking when they are solvable, and it's always very good in these kind of exams to be able to say, well, why would it not be solvable? What would need to happen so that this is not solvable? And one of the other challenges here is remembering that theta is an unknown constant. Yes, that constant can be set at different values, but it is x and y that are our variables. Theta is set for an equation. So what kind of equations are these? Are they linear? Are they non-linear? Remember that theta is a constant to be set. And why would the simultaneous equations not be solvable? Finally, our logic question. Now, there is a note here because this references the trapezium rule. Now, the trapezium rule is not on the TMUA specification. It was on the MAT. But Tobin's chosen this question because the vast, vast majority of people sitting TMUA will have covered maths in year 13, and therefore at this point will have studied the trapezium rule anyway. If you haven't, then just feel free to skip this question. Now, one of the things with these logic questions is be careful about any assumptions you are making. It will be very easy to assume, for example, that this graph looks something like this, where this is, say, x equals 1. Does it have to look like that? What else could it look like? Does it have to be positive values of x? Of y, of f of x. Could it be negative values? Could it be both? So you might think that several of these are true, but we're looking for the one that has to be true, regardless of f of x, because they have not told us anything about what kind of function f of x is or what it looks like. So you are looking to use a sort of if then. So if this is an overestimate, then one of these is definitely true. So think carefully about that one. Consider the different ways f of x could look and think about these as transformations. Okay. I hope this video has been helpful. Any feedback always appreciated.